Welcome to the KNIT Spring 22 webinar update presented by Ilya Baldin, Anita Nikolic, and Paul Ruth. We know that spring schedules fill quickly, and we sincerely appreciate you taking the time to hear about a few exciting updates. The Fabric Testbed leadership team will use the hour to provide site installation status updates, share new features on the testbed, and introduce tutorial sessions and videos. Additionally, the lead team will discuss how the platform enables novel approaches to distributed and network systems control and management by integrating artificial intelligence, and how users can utilize the AI capabilities in their proposals, papers, workshops, and more. Today's presentations will last about 40 minutes with 10 minutes for Q&A. Up first, we have Ilya Baldin, who will provide a deployment update focusing on site installation. Baldin leads RENCI's network research and infrastructure programs. He is a networking researcher with a wide range of interests, including high-speed optical network architectures, cross-layer interactions, novel signaling schemes, and network security. Paul Ruth will address new features on the testbed, reference tutorial videos, and the importance of our new user webinar series. Paul is the Assistant Director at the Network Research and Infrastructure Group, INRIG, at RENCI, UNC Chapel Hill. His research interests include building and using dynamic cloud computing and network testbeds for software, defined exchanges targeted at data-driven scientific workflows, and finally, Anita Nikolic will share a call for AI projects with special attention on workshops to target. Anita is a research scientist and director of research innovation at the Information School at UIUC. She served as program director for cybersecurity at the National Science Foundation and was the executive director of infrastructure at the University of Chicago. And she's held a variety of research and operational roles in both industry and government. So without further delay, let's go ahead and get started. Ilya.
Thank you, Amanda. Hello, everyone. Thank you for sharing your afternoon with us. So I'm going to, just for a few minutes, talk about where Fabric is and where we're going, and leave the majority of time for Paul and Anita to talk about more exciting, interesting technical details. So first of all, where we are today is these two pictures. We have two separate topologies that are running. One of them we call Fabric Development Ring, and one is the Fabric Production Topology. They're independent of each other, and they're needed for kind of serve the two purposes that we have right now, which is supporting our early experimenters on the production topology, and then continuing to do the development of software and other features on the development ring. There are essentially two copies of infrastructure exist for everything, and so that includes a portal and any backend systems and Jupyter Hub and so on. On the right is the picture as the topology as we know it today. As you can see, we have a number of dark blue solid links, and these are actually 100 gig dedicated DWDM systems that we have supporting Fabric. This is unique. I think we're maybe unique in the sense that we now have our own dedicated DWDM optical footprint. And as time goes forward, we're going to increase that. As you can see, we have a total of 13 sites available, and then we're still waiting on delivery of a number of them of phase 1 sites for hardware. This is where we're expecting to be by the third quarter of this year. Using the federal fiscal year, starting in October, basically. We expect additional sites to show up, UCSD, GPN, FIU, Clemson, and Georgia Tech. Unfortunately, they've been delayed quite a bit. A number of them were actually ordered last year in July. We're still waiting on the hardware to arrive. But there's light at the end of the tunnel. figuratively speaking. And so we hope to complete this part of the deployment soon. We also, as you can see, we have appearing a little cloud icons, and this is something we're actively working on right now. We just signed the agreements with Internet 2 to support these appearing points. And that means that our topologies soon, the experimental topologies will stop being sandboxes and will become optionally, by request from the experimenter, connectable to the public internet, which is an exciting development, and a number of experimenters have been asking for it. This is where we're going in the near future. This is our phase 2. As you can see, we have a much larger number of dark blue solid links that will be our own DWDM system. A lot more sites. These sites are being ordered from our vendors. The equipment for them is being ordered from our vendors right now. We've actually already received some of it. So things are kind of progressing quite well. Also, we will be paying a lot more attention going forward to connecting facilities to Fabric. This is, again, we were waiting on some features to develop in the software stack, which have now been developed. And so we will be actively talking to some of you, many of you, to connect your facilities to Fabric and make them available to Fabric experimenters. On Fab, again, we're experiencing a number of logistical problems there. We expect the CERN site to be delivered sometime during the summer, perhaps early fall. And then the other 3 sites, Bristol, Amsterdam, and Tokyo, are currently at various stages of ordering process, and we're hoping to complete them as soon as the logistical difficulties allow us. In terms of what you can see today as an experimenter, there's a number of things running, kind of going from the top clockwise. We have the Fabric knowledge base user forums at learn.fabrictestbed.net, and you can see documentation, you can see user forums that users, experimenters can participate in and ask questions of each other or of us. It's basically the information hub for the entire facility. We have a portal, portal.fabrictestbed.net. You can probably see the theme here in the naming. That is, again, usable by our experimenters. They can see their slice topologies, and pretty soon they'll be able to create their slice topologies graphically from that portal. They can manage their credentials and so on and so forth. So it is going clockwise 1, 2, 3, 4. There's a graphical slice viewer, and then finally the last one is a Jupyter Hub. Again, there's an operational Jupyter Hub that experimenters can use. All of our experiments are today packaged and published as Jupyter notebooks, which is great. It creates essentially reproducible artifacts that can be replayed by others on the testbed, and that's very useful from our perspective for our community. And also makes it possible for us to kind of riff and evolve of existing notebooks and create more sophisticated experiments, and Paul will be showing those just as soon as I'm finished. We have a number of early experimenter activities, even though we're not in operation officially yet. We have a number of early experimenter activities going on, and we're essentially starting to admit early experimenters based on the order in which they requested to join, and limited only by the capacity of the testbed at this point. That is growing, of course. We have 80+ experimenters active who are not part of the Fabric team, and 15 projects registered in the portal. And here, I'm not going to go through all of these, but you can see we have actually a pretty good sample of different variety of types of experimental activities that are going on. Reinforcement RL-based DDoS defense, petascale file transfers, anonymization experiments, smart sensors, data lakes, etc., etc., etc. So these are all in stages of using Fabric infrastructure and attempting to run portions of their experiments on that infrastructure. And as I mentioned, we're adding features like the ability to federate with other testbeds or peer with public internet that will make those experiments even more powerful. So this is, we call this NIT 4.5 because this is a webinar, not a full workshop, but we do plan to have a full workshop in the fall called NIT 5. And some of the things that we're expecting to be available to experimenters before we get there are As I mentioned, facility ports, mirror ports are actually being tested right now. Should be available within just a couple of weeks. We expect to have IPv4 and IPv6 based peering with production networks from your slices, which again is something that's very often asked nowadays. We've acquired a /22 of public IPv4, in addition to already /36 that we had of public IPv6 addresses. We expect to integrate with a peering testbed with Ethan Katz-Bassett's peering testbed and make that the resources available to the peering testbed from Fabric. Paul is going to talk about something called Fablib, which is a user-facing library that is growing in its capabilities and essentially has become the de facto standard of how you interact with Fabric. We expect a tighter integration with measurement framework capabilities for collecting experiment data in a more automated fashion, so that this is not so this is just something that reduces the friction in creating your experiment with a few presses of a button and some configuration statements. You can have your data collected in the way that you prefer. Working on UI capabilities for education-focused scenarios and much, much more. And at this point, I will stop and let Paul continue from here.
Okay. All right. Let me share the right screen. This one. All right, so you guys can see my window here, I think. Let me see if I can make it so I can see you guys. It's easier to talk that way. All right, so I'm going to just go over a few of the new capabilities we have. There's quite a few of these new capabilities, and I only have about 20 minutes scheduled, so I'm just going to give a high-level view of it and then show one quick example on how some of these features work. Oops, select over here. Some of the big new features, like the biggest one might be that there's 10 sites now, which is pretty good. We're deploying new sites. Seems like every few weeks there's another one these days. So we have 10 of them out there. This is where they are. This was actually run. I ran it yesterday to like query the system to pull what's active. If you count those circles, it looks like there's actually 8, but there's really 10 because there's in Salt Lake City, there's one site that's at the co-location with ESNet 6 and another one at University of Utah. And in Washington, DC, there's one co-located with ESNet 6. And then there's another one at Max in University of Maryland. The rest of the sites are Dallas and TAC and Starlight, UIUC, which is NCSA, and University of Michigan, and then UMass, which is at the MGHPCC. So those are the 10 sites we have, and then we have our dedicated links between them in this particular topology. That'll get updated pretty fast, I think. So like this will change by the time you come and check it next week, probably. There's one of the other main new features, one of the biggest ones we have, is an API, a new API called Fablib. This is like Ilya said, the de facto way you should interact with Fabric going forward. I will show you an example of this going forward or in a minute, so I won't say too much about it here. And like Ilya said, we have like you saw last time we talked to you at the previous NIT workshop that we had Layer 2 network circuits that we could deploy across the wide area. We still have that. It works even better than before because there's fewer bugs now. A lot of bug solving in the last 6 months or so. But one of the new features we have is this L3 data plane that is available. We call it Fabnet v4 and Fabnet v6. So obviously that means that the Fabnet v4 is based on IPv4 and the Fabnet v6 is based on IPv6. And what these are you can kind of think of them as a separate internet that is deployed just across the Fabric sites. And you can create subnets on these Fabric sites that are connected to this network. And we'll show you an example of how to use this in a minute. We also have some increased security. You now have to SSH to all of your nodes over SSH or over Bastion hosts. So we now have a bunch of SSH keys you have to manage, and the Fablab library helps you manage that a bit. And then the portal has a place where you can create and register these SSH keys, and I'll briefly show you that in a second. There's a few portal updates. There's more docs, and the forum has some updates that make it easier to use. And then the Jupyter examples, the examples that we have on Jupyter Hub are expanding. So that's what we have. That's the main new features we have. I select this over here. Can I select over here? So the Fablab API, I will show you an example in a minute. And that's probably the most useful way to look at this. But what it is a Python library for using Fabric. You can pip install it right now if you wanted to, although you wouldn't have the tokens and credentials to use it yet, unless you have a project. So all of the software we have is going to be available via PyPy, so you should be able to just install it wherever you like. The bonus of our Jupyter Hub, or really the purpose of us having Jupyter Hub, is all of these tools will come pre-installed. Everyone who's dealt with these test beds in the past knows that like some of the biggest headaches is trying to install the various tools on all the users' machines. Jupyter Hub means that we get to create your environment for you, and it should always work. So that's the recommended way to at least get started with Fabric is Jupyter Hub. All these tools will be pre-installed there. Fablib does more than just interact with Fabric. That's kind of one of the bonus pieces of it. So there is the Fabric native interface, and it allows you to create and destroy different pieces or slices and slivers in those slices. Fablib is actually going to add some features on top of that to help you manage your experiments, as well as allow the underlying APIs to evolve over time and provide new features without changing the interface going forward. So Fablib is the API you should be using when you use Fabric. It should remain as stable as possible. That's our hope for that. Any changes to the underlying infrastructure, we will try to wrap them up in Fablib and make it as painless as possible for the user. Yeah, I'll show you some documentation about it in a minute as well. On the portal, Ilya hinted earlier, there was a picture, and I will show you a live version of it in a minute. One of the main things we have on the portal is we now have a graphical slice viewer, so you can actually create a slice, and you can go to the portal and you can bring up a viewer, and it's, you can click on it and drag things around, kind of like you might be used to if you used Fabric or used Genie or something like that in the past. And like Ilya hinted, that will evolve into a graphical slice editor as well. So you can be able to create these slices and modify them eventually. But for now, you can just view them. Also on the portal, we have a way for you to manage your bastion host keys. And it kind of sits next to a place where you're eventually going to be able to manage the keys for your slices. That's coming soon. So I'll show you a little bit about that in a minute too. The knowledge base, there's not a whole lot of changes there. There was some frustration with how you logged in to the forum. We simplified that. That should be a lot easier to do. Even if you don't have an account on Fabric, you can go to learn.fabrictestbed.net and log into the forum using your institutional in-common account. So if you want to subscribe to the forum and and read about the questions people are asking, or maybe ask questions yourself that maybe don't have to do with using Fabric, feel free to go ahead and do that. You can even subscribe to, there's a forum on there that's about announcements. You might not subscribe to that, and you will get email notifications when there's a new topic and things like that. So it might be useful to sign up for the forum, even if you don't have an account, but you will soon have an account if you want one. Next, Jupyter Hub. So the updates to the Jupyter Hub, the main things, if you have been using Fabric since maybe last summer or so, you might have noticed a few months ago the examples in Jupyter Hub changed. And basically what we did is we took all of the examples that we had there and we rewrote them using the Fablab API. Hopefully people that have had experience with both sides of that, and they look at the Fablab and they hopefully think the Fablab is better and easier and maybe more stable to use. If you don't feel that way, or even if you do feel that way, let us know. We want to have feedback about Fablab and how it works and what you feel about it and what you might want to change. So let us know. So the main change is we have a bunch of example notebooks using Fablab, and it should be a lot easier to use. And the other thing that we've added is examples on how to use the FabNet, so the layer 3 data plane services, which I will show you in a second. Yeah, I was going to show you things and then I'm going to tell you what's coming soon. Okay, so we go to, it's over here. If we go to the portal, this is what the portal looks like. It looks more or less the same as before. There's probably some updates, but I don't remember what was updated since we last talked here. If you are using it, note we do have a power outage at Renzi starting at midnight tonight for a couple hours, so don't run anything overnight tonight. So we'll go ahead and log in. I'll log in with my UNC identity. Most everything up here on the portal is the same. Like one of the main changes here is if you go to the slices, the experiments, and then you look at your slices, you can see a list of all of your active slices. I started one earlier just so I can demonstrate this. There's an example that we're going to put in the notebooks that does OSPF routing via some virtual machines. And this is a version of that slice that I have up, and it's stable and running and so forth. If you click on it here, you'll get this graphical interface. And if I zoom the right way, you can get everything on the same screen maybe. You can see in this particular example, this has 3 sites. The gray boxes are sites. This one's at Starlight, this one's at University of Utah, and this one's at Max at University of Maryland. And inside these, there's, this is a virtual machine at Starlight, and there's 2 more virtual machines at Starlight, and they're connected with a local network here. And then you can see that same thing is true about the 2 other sites, Utah and Max. There's 2 nodes connected to a network, which is connected to a 3rd node. And then the 3 nodes in the triangle here in the middle are connected to each other in a triangle. And we have, you can't see this here, but you can, running in it is the FR routing, which is the updated version of Quagga. So if you've used Quagga before, then FR routing is the new thing. You should try that. And they're running OSPF, and you can manipulate it and update it and make these VMs talk to each other over the routers, and that's there. But you can see the main point of this picture is to show you the graphical viewer. You also notice if you click on any of these, you can see information about it on the side. You can download a JSON description of it, download a PNG. Like if you wanted to use this picture in one of your papers or presentation, you could just download the PNG and use it. The other thing that's worth noting here is if you go into, not projects, but I think experiments, you go down to SSH keys. Here you can see everyone has a Bastion login ID, and this happens to be mine, but yours is there and it's been assigned to you. It has your emails prefix in it, assigned with your ID inside of the Fabric system combined with it. And that way they're both unique and we can read it. We can read it as humans and figure things out. There's 2 types of keys that we have here. The Sliver keys are not yet implemented, so don't try to use this for now. This is a way to manage SSH keys that will go into your VMs and different resources that you have. I think we can upload keys, but we don't actually use them yet, so don't try to. But the Bastion keys do work and are required, so you can actually manage a list of up to 10 Bastion host keys. You can either have us create the key and you can download them, or you can upload keys that you created yourself if you don't trust us with your private key, which you shouldn't, but you might. So this is, if you register keys here, they will be available in the system. You'll be able to use them when you use your slices. All right. So those are the 2 main things that we have new on the portal. On the knowledge base, you might have seen this before. We have some more updated information. So if you go into the technical user guide, there's the Fablab API article here. And if you go into the Fablab API, you can see some detailed information that was generated with Sphinx. So this will actually show you the different objects you can interact with the Fablab API and all the methods that they implement and what parameters they take and what they do and so forth. So hopefully people start using Fablab API and start reading this and then tell me all the problems with it. Like if I said something wrong, or if you don't understand something, let me know, and then I can update the documentation appropriately. So, and then, and over here, I'll go with the knowledge base again. The other thing is the forums. If you want to go to the forums, big button here says go to the forum. You're in the forum. It used to be kind of awkward to log in, but now that we have this button up here, if you log in, you can log in. Notice it takes you to the same CI login page. You can log in with your institutional identity, and now you're logged in, and you can post and write comments to everyone else. You can go to like the general discussion site, and you can see all the people that have been asking questions, and you can interact with them if you like. So that's useful. Okay, and then the final thing is just a little demo of what some things that work now. So if we go to the Jupyter Hub, which hopefully you've all sort of seen a little bit, again, you log in with your institutional ID. I can make it remember this, but I have to, I'd like to show people that's how it works, because I'm doing demos a lot for this. So this is just a regular Jupyter Hub that you might be familiar with. Mine's configured. I've already put my Bastion key in here so that I can access things. If I go to this Jupyter Examples directory and click Start here, this is an index of a bunch of the other notebooks we have, and you can go ahead and run them. There's examples on how to do most of the basic things. We're going to add more to this over time, including more complex recipes. Right now, there's a Kubernetes cluster here, but that FR routing one will be here eventually, and some security ones using Zeek, I think we're planning, stuff like that. For now, just for this short demo, because I don't have a terrible amount of time, I'm going to go down to this Fabnet IPv4 layer 3 network notebook and just sort of talk to you about how this works. So if you've seen this before, you probably weren't familiar with the way Fablib works. So Fablib starts off with just setting up some environment variables. If you're using our Jupyter Hub, these first three are set up for you, so you don't have to do it. Like when you logged into Jupyter Hub, these were set for you. And we actually have a way to like automatically assign some of these other ones. We just haven't implemented it yet, so we'll get there eventually. For now, the only thing you have to change is your Fabric username, which if you go back to your portal, you can just copy it from your SSH key page and paste it here, and then you should be good to go. Now, if you run the first cell here, it configures your environment. The next thing, it will import the library and set some things up. If you remember right before, you had to set up a bunch of proxies and a bunch of other things, and it was kind of confusing and it failed a little bit. So now we have a bunch of things. It automatically configures a lot of the proxies for you, and you don't have to worry about that. We also have some simple calls to do something like this. Like with this, just you say Fablib and you just list the sites and print that off. This is going to show you a text-based list of all the sites that are available and all the resources that are available at each one. Take a little minute because I just started this, but hopefully it gets there. Yeah, so here you can see that the 10 sites I told you about are all listed there, and they all have various numbers of different kinds of NICs and such. You can see that we're pretty underutilized right now. That's why we're going to ramp up the number of users coming up soon. So if you don't have an account and you want an account, pay attention. We're going to have some onboarding sessions over the next few months. There will be emails sent out, I think tomorrow, if I remember right, but I'm not in charge of that part. Yeah, so here we have our 10 sites, and you can see how many of each of the types of resources are available right now. Then if you want to use Fablib, like one of the things you might want to do, in this particular case, I'm going to do this wide area layer 3 Fabnet v4 experiment. So what I want to do is get a couple of sites, and I didn't run a hard code sites in here because then all the users using these examples use the same sites over and over again. And then 2 or 3 sites get overloaded, and oh, by the way, those sites also, when they go down, then none of the examples work. So we now have in Fablib, you can say get random sites. And in this case, I want 2 random sites. So I get 2 random sites. In this case, I got TAC and Dallas, which those are, I don't like those 2. They're too close together. I'm going to go do it again. Max and TAC, that's better. Okay, so at least they're on different sides of the country. Yeah, and then, so now we have our sites and we have names for our nodes and networks and so forth. And this is where Fablib makes things a lot easier. So here, you just say fablib.new slice and you name the slice and you get the slice. I'm actually going to hit submit so this can run in the background while I'm talking about it. So this is how you create a new slice in Fablib. You just say get the new slice and then name it. Then you can take that slice and you can add a node, name that slice, and say what site you want it to go to. If you don't put a site there, it'll pick a random one for you. In this particular case, I needed to pick the random ones because I wanted them to for sure be different. So I picked the random 2 sites before I submitted, but if I took the sites off, it would just pick random ones for you. You can also add extra parameters here to your nodes with the number of cores, amount of RAM, amount of disk, and a couple other things like which image type you want to use and so forth. It'll do some same defaults for you for now. So here we add a node to our slice, and then we're going to add a component to the slice. And a component is just a PCI device. In this case, you can see up here the types of components. These are the 3 network components that we have. We're going to do a basic NIC in this case because there's lots of them available. And they basically are SROV virtual functions that are on a 100 gig ConnectX 6 card. It's your PCI device, but it's a virtual function on the card. It's 100 gigs, but you're also sharing that bandwidth with anyone else that has a virtual function on the same card. So you have to be aware of that. If you ask for the ConnectX 5s, the ConnectX 5s or 6s, you get the whole card to yourself, and they actually have 2 ports each, and they're dedicated to just you, right? But so use the basic NICs if you can, and the ConnectX, the dedicated cards if you need to. So in here, what we do is we add a component of type basic NIC to the node. We name it. Since that NIC that component is a NIC, it has interfaces. We can get the interfaces off that. And since it's a basic NIC, it has exactly 1 interface. So it's in the list of interfaces, it's in position 0. If you did a ConnectX 6, there would be 2 NICs there, and you can use either one. So we add a node to the slice. We add a component to the node. We do that again for another node. And then down here, we create 2 different networks. In this case, the networks are 1 for each set of nodes that are on each site. So in this case, we're going to have a network that's on the same site as node 1 and a network that's on the same site as node 2. And we're going to set that up by saying the interfaces that should be on that network is in this list. In this case, it's interface 1, which is on node 1. In this case, it's interface 2, that's on node 2. And then IPv4, so you get a Fabnet v4 network. If you said IPv6, you get a v6 network, and so forth. And then you hit slice.submit. And when you submit the slice, as you guys were probably watching in the background, this is what happens. You see sort of an updating progress bar of what's going on. In this case, we have our 2 sites, one at max and one at TAC. These are the actual hosts they landed on. These are the amount of core RAM and disk. These are just kind of the default core RAM and disk that you get. If you don't specify anything, the default image is Rocky 8, because CentOS 8 is no longer supported, so we're moving to Rocky most likely. Oh, and the unfortunate thing about having Max and TAC be the 2 at hit is they happen to be the 2 that have management IPs that are IPv4. If you got any other site, one of these would be an IPv6 address, which would be an interesting thing to talk about, but it didn't happen. So just know that this notebook works perfectly well if you do IPv6. And then we have some state here. We try to SSH to it, and we make sure you can SSH to it, run some post-boot config information. And then we pull out the 2 NICs, and we can see that they happen to be ETH1 in both of the nodes, and that's fine. And there's the MAC addresses, right? Okay, so that was all done in just that short amount of code up there. Now we can print off some information about each of them. So here's what a slice looks like. You just say get the slice, and it happens to be stable okay. Here's what each of the nodes, the information that I showed above. If you want even more detailed information about the nodes, you can print them off individually. And one of the more interesting, more useful things in here is this SSH command. So this command right here is the command that you would type if you wanted to SSH into the node from a terminal in this Jupyter notebook. So if I went up here and I grabbed myself a terminal, I should be able to whoops. I have to cut and paste that first, right? I should be able to SSH in here. Oops. Oh yeah, because I have to do hello fabric. have to set up I cleaned up my whole system and I forgot to set up my Bastion key pair using this other notebook that I'm not going to talk about today because it'll take too long. But now if I set that up, I should be able to SSH here. And now I'm into my node, and it's just the node that I logged into, or that I created over here. Yeah, over here. All right. I'm probably running out of time, but so here we can print the interfaces, which looks like exactly what I showed you before. And now we get to the interesting part where you can assign the IP addresses. So in this case, what this does, if I'll print this off here. So we get the network by name, and remember there's a network on either of the sites that we have, one at Max and one at TAC. And these networks are a subnet specified to your project that you can now assign to any VMs in your project that are connected to this network. And what you get with that subnet is a subnet that is on our Fabnet v4 internet, and a gateway that you can assign to your node. So if you give an IP address out of this subnet to these VMs and set them up so that they have this gateway, you'll be able to communicate with anyone else or any other VM that's on this network, on the Fabnet v4. And you can see we got two different networks here, and they have two different gateways and two different subnets, and they're on two different sites for that matter. So what I did here is I can get the network, and then I can pull off that network the available IPs, which just takes that subnet and pulls the ones that are available that I haven't assigned. Then Fabnet actually has some code in here that I won't get too detailed in, but it has, if you get a node, if you get your node, you can get the interfaces from the node, and then you can add IP addresses to that interface. And here I'm going to use an address that I popped out of the available addresses, and then I'm going to use the subnet that I got from the network. So I'll just go ahead and run that. And then what will happen is it'll also add a route here. And this is adding a route to the other network subnet via my gateway. And this is how this works. So now you have two subnets, and they can talk to each other because they have the route set up. You want to be pretty careful here that you don't just make it your default gateway, because keep in mind, you need to SSH into this node over the management plane. If you make a default gateway, you cut yourself off from the management plane. So you got to be a little careful there. So we do that on the other side, but just in reverse. And you can see now that once we show the addresses on the interfaces and then the routes, we can see that this node got this IP address, and it has the correct routes to the other side if we want to look carefully there. And this one has this address and the correct routes to the other side. And here I'm just going to go through and I'm going to say node.execute, which actually SSHs into the node and runs a command. And I'm going to ping the other node's address I'm going to ping node 2's data plane address from node 1 5 times, and then print off the standard, hopefully standard out and not standard error. So we'll see what happens. So it should take at least 5 seconds to run this, plus a little overhead. And you can see that it worked. It came back and it said it took 124 milliseconds because one's in Maryland and one's in Texas. So yeah, and then if you want to be nice, you can come down here and delete your slices. So this was just sort of a simple example of how Fablab works inside of our Jupyter Hub, and a little, demonstration of how our Fabnet networks are supposed to work, and how you can do layer 3 things. So there was no layer 2 that you had here, although layer 2 is still available. Yeah, okay, so that's that example. Hopefully we can ask questions about it in a minute. The last thing I had down here was things that are going to come soon. And by soon, I mean in the next few weeks, we're going to deploy this. We're going to have project level resource authorization. So we have a way to control which projects can access which types of resources. That's beneficial because some of the resources are really scarce. And if you want access to those, then we need to control access to them so that you have privileged access to certain scarce resources. Like I said, I've mentioned before, there's going to be a graphical slice builder that's going to look a lot like the slice viewer that I showed you. We have facility ports. So these are layer 2 connections that connect from Fabric to external facilities. Chameleon at University of Chicago will be the first one, and it's in progress right now. And we'll add lots more of them later. Mirror ports, these are going to mirror traffic from a physical port in Fabric to your slice. And this is something you can think of like attaching a Zeek to it so you can monitor traffic on Fabric for your experiment. We'll have a lot more slice configuration tools where we have, IPs, routes, and scripts will be done in better ways, and monitoring. Jim Griffon, that's on the call, is working with a lot of people to allow you to really easily monitor what's going on in your slice. And there's too many parameters that you can monitor to even begin to mention here. And then Fablib will have a lot more convenience features as well as implement interfaces to all the other capabilities that we mentioned. Please use Fablib and tell me what you think about it. Anything you want to be added to it or anything that's done poorly, we'd like to know so that we can get it implemented as soon as possible. All right. Thank you. And I think next is Anita, unless we're supposed to do questions now. I don't know.
You're correct, Paul. Next up is Anita, and then we'll be doing Q&A.
Okay. Stop share.
Okay, I am not on my normal computer, so apologies if I seem discombobulated. Can everybody see that slideshow? Okay. So I want you to suspend your disbelief a little bit and think broadly about AI ML experiments. I know this AI ML is the new hotness, but we are trying to entice our community to think beyond kind of our traditional networking experiments. So we really are trying to encourage some kind of non-traditional. I'm going to talk about a couple types of ML AI types of experiments we want to encourage. So in the past 5 years, there's been over 5,000 papers on adversarial AI. This is one of the areas that I've been working in the past couple of years. And so I'm going to encourage people who have colleagues or talk to people in this area to really think about using Fabric, and I'll explain what that means. So let's start with a few areas where we think we can get some interesting experiments, and I'll move on to maybe AI for science. That's more relevant for some people. So federated learning is also very hot. People tend to do this in their own kind of test beds, where this is, a way of learning by taking data from a bunch of edge devices and not having to draw your data back to a data center, but how can you, train across multiple sites, across multiple edge devices. Fabric's a great place to do this because we're distributed all over. So if you have something you want to test out at scale, this is, we have IoT experiments, and we would love to encourage more of this. And I'm not going to be really prescriptive in what I'm suggesting. I just want to give some opportunities for people. So we also connect to, these new AI supercomputers, such as at PSC, there's Neocortex. These are all in the line, on Fabric. So are there interesting ways you can include these into your workloads or workflow? We don't have anything necessarily prescriptive, but PSC, the folks at Neocortex, do you want to work with us? So if there's something really interesting that can be done with it, we want to hear about it. Machine learning for, network decision making. We often, if you deal with vendors, you hear this all the time, self-driving network. But what does this really mean? And do people, what are some things we can encourage in this area? So we have a lot of data in the Fabric ecosystem. We have thousands and thousands of data fields, which you can show you in our master huge spreadsheet. What can you do with our data? It's there. We want to share it. We want people to do interesting things. What can you do to make better network decision making? Maybe things that aren't done today. So these are two areas I'd like to encourage. And they're two kind of different areas. Machine learning for security, kind of AI-powered cybersecurity. And Phil Porras at SRI is doing some of this. There's someone at Rochester, Jay Yang, who has something called Assert, who's also doing this. But what can you do with all this data that Fabric's collecting on the infrastructure, and how can you make security decisions? So this is at scale. This is huge amounts of data. how can you automatically, correlate data to make security decisions at scale? One of my pet areas I'd really like to encourage people to think about is machine learning security. This is security of the models. And this is really important for science and other things. A lot of industry has shown that there's a huge number of people in industry are unprepared. They don't know how to secure their machine learning models that are making decisions. They don't know where they're vulnerable. Fabric's a great place to try to safely attack models in order to construct defenses. And we've been talking to another mid-scale called Sage, and potentially, can we attack those models at the edge to make their defenses better? So how can you help your security people demonstrate some realistic adversarial attacks on machine learning? We see a lot of this in the press of like attacking a Tesla and attacking the models. Not a lot of it's done in practice. We would like to encourage this testing to be done on Fabric. We collect a lot of data, thousands of points of data. You can generate data sets that can be used and shared for training and evaluating machine learning-based solutions for your favorite vertical of choice, networking, security, distributed systems, and you can deploy it on Fabric and try it out. This isn't particularly machine learning related, but in a workshop last December, we asked for some community ideas on dangerous experiments. So you want to encourage, kind of tongue in cheek, what's a really kind of groundbreaking experiment you could try? So you could try to do things like polluting edge computing data. You can do it safely before it's done in practice. Pattern recognition on your network, maybe some blue red team challenges. These are just a small subset, and I would ask our NSF friends to help us point to more, but an existing pool of experimenters potentially. Of course, there's these great programs that are funded. We don't have a lot of people from these programs that are using Fabric. We would love to get out to them. So your friends on campuses or labs, encourage them. Machine learning accelerated science. So just, we'll hear more about this in the workshop later in the year, but just to let folks know, primarily through Fab, which is our IRNC project, we are working with science projects to integrate compute and networking into the workflow. So CERN, CMBS4, LSST, you can see the little picture down there. I see Sean McKee's on the webinar. Sean and Robert doing some great stuff with CERN to get GPUs into the workflow. We're working very closely with CMB, which is an NSF-DOE project, to simulate the path and prepare their future workflows for integrating some of these decision-making. Some other projects to check out. We are potentially connecting to a DARPA adversarial machine learning testbed that's kind of in the works still. Again, it's to show, it's a testbed that DARPA is doing for characterizing machine learning defenses, and it'd be great to partner up with them. Some case studies are here if you're wondering what the hell I'm talking about, and this is just a quick talk. Go check this out. This probably describes it better than I can in 7 minutes. On to a couple of partners. We are partnered through Fab, University of Amsterdam. They are looking for some cross-Atlantic experiments in federated learning, security, decentralized systems, in this building the responsible internet. Shout out to Bridges. I think Jerry Sobieski is on the webinar. You can probably ask him some questions in the Q&A. Bridges looks to be up and running, if not now, then very, very soon. And there are friends in the IRNC program. Other friends in the program, Cosmic, I see Yvonne is on the webinar, Cosmos. So they are not only partners in the US, but also with our international connections. So if you feel you have a great experiment to connect with them, please do. And Sage, another smaller mid-scale that's doing science at the edge, and we are potentially going to work with them to secure their machine learning models at their edge devices. And that's a quick tour, and that's all I had.
Excellent. Thanks so much, Anita. So folks, we are ready to get started with the Q&A portion. This is a great time to either, and if any of our panelists disagree, I think it's fine for you to unmute yourself and ask if you would like to be on screen, or you can always pop a question in the chat. We have all of you should have chat functionality, and I can correct that if I need to.
Everybody understands completely.
Mhm.
People are trying to write in the chat probably.
Amanda, did you mention our in-person workshop later in the year, perhaps?
You ruined my closer.
Oh, sorry. Okay, hold that thought.
Now they're going to have to stick around until the very end. All right, it looks like we have a question from Nick at Illinois Tech. Paul, do you see that in the chat? You want to
Yeah.
read it out loud?
Yeah, so the question is there a way to use the Fablab library to ramp up students before using live Fabric resources? Is it possible to run a sandbox or virtualize for learning purposes? Possibly. I mean, I think that a lot of what's going to happen though is like it'd be more useful to just use it in real life. Yeah, I don't know. I'd have to think about running something in the back end that would give you feedback to, like, once you query for it, like, you know, what slice did or what site did it go to, or like, you know, did it work, or like what's the management IP that you would log into. If you want students to use it, I think we're kind of looking for more people to use it. So maybe just create accounts for your students, unless somebody tells me otherwise. Then the other question is not really a question. It says waiting for researchers to tell me they want to connect. So I'm not sure how to answer that. That's potentially maybe what the the answer is, or what, you know, for all of this is watch out for the announcement that I think is going out tomorrow. That's going to share with you I think we have like one day every month for the next some number of months, where if you want to get started and have a project and onboard users, and we will we'll have a couple hours session where you can show up. We will try to get your account set up, try to walk you through some of the basic examples of Fablib on the Jupyter Hub, and let you ask questions. So. Oh, that's Anita answering that question. I don't know. so yeah, I don't know. Ilya, do you have anything else to say? I guess one question here is, like, for AI ML projects, is there any examples or code to start using Fabric ML Testbed? I think the way to think about this is really when you get, and I guess we didn't talk about that today as much because we talked about it in previous workshops, but the way this works is that when you create a slice and you want to use a GPU to do some AI things, you just get that PCI device is passed through to your VM via PCI pass-through, and you have the whole card dedicated to yourself to do whatever it is that you want to do. So you can just run whatever AI ML software stack you would like to use. We have two different kinds of GPUs, the RX 6000s and RTX 6000s and the Tesla T4s. You can use whichever one. They're pretty underutilized now. So if you have a project that you wants to use them, we would like someone to exercise them. So go for it. I don't know if that answers the question. Yeah, so the question about managing them graphically, there's a couple efforts we have towards that. Like the one that I kind of showed you, the viewer, there's going to be a graphical editor that goes with that. So it's going to look the same way, and there'll be a way for you to use that viewer that I showed you. I was dragging around the different nodes and things. There's a way to draw that graphically using the same tool basically, and then submit it that way. There's also some work we've done inside of Jupyter Hub to use something called like Api widgets, so that you could actually inside of Jupyter Hub do things graphically. There's some work that's been done on that, but that's not there yet. It's not usable yet. I mean, it's usable in like a very, very basic way, but probably not good enough for actual users to use it. And I don't know about the timeline.
Well, the slice editor will be available in just a couple of weeks.
Yeah, okay, true.
But just as a note, we're really aiming for the graphical features to be more targeted towards students, simpler kind of scenarios. And if you want to take advantage of the full power of the test bed, it's really Jupyter Hub and Fablib. That's your main gateway to doing that. It's just graphical representations tend to confuse and hide a lot of things that you can't, you can otherwise specify using something more scriptable like a notebook.
Also, we're trying to encourage, I mean, this is more of a general systems research thing that effort that the whole community is working towards. We're trying to encourage you to package your experiment in a way that somebody else can reproduce it. And generally, if you created it by hand using a graphical tool or logged in and configured everything, it's not reproducible by someone else. And you might even argue that if you did it yourself, you don't really necessarily know what happened in there. If you're not able to script it, then do you really know what's going on? So anyway, we're trying to encourage people to write these in terms with APIs and code and package them in notebooks, so that you can take that notebook and give it to somebody else who can reproduce it. And we actually have some efforts kind of collaborating with the Chameleon project, Chameleon Cloud, through a thing that they have called Trovy, where you could actually take Jupyter notebooks, package them in a shareable format, and then publish them and get a DOI for them. And that way you can actually take your Fabric and/or Chameleon experiment and publish the experiment, not the paper describing the experiment, but the experiment itself, and then write your paper and cite the experiment with its own DOI, and with the idea that somebody else could read your paper, go get that experiment, and then open it up and reproduce it themselves. So, yeah. So there's a question for Anita.
Yes. Yeah, absolutely. That's something Jim Grafone has, and I'm more than happy. I owe you a meeting anyway, Nick. You and I are supposed to sync up. So yes, I can share that with you and publicly available. I know we had shared it at our last workshop. I don't know if there's a link on the on our site, but yeah, it is publicly. We can make it publicly available.
So it looks like we've got another question from Ellie.
Yeah. So there's a few things here. One thing we didn't mention. So the question is it possible to configure the physical routers and switchers and use features like QoS, buffering, etc.? So two things. One, quality of service is coming. The quality of QoS matters less when you're talking about within one site, because generally speaking, like if you have one of the ConnectX 6 or 5 cards, you have the entire port to yourself and you have the entire port on the switch. So it's basically full bandwidth. So if it's 100 gigs, it's 100 gigs. If you want to rate limit it, you can run something like TC yourself inside your node. So it's like in terms of quality of service, if you're running within one site, you just have full bandwidth that is available on the switch. Between sites, the wide area connections, we're actually going to have quality of service guarantees built into the system eventually. It's not there yet, but what you'll be able to do when you create these wide area connections, you'll be able to say like, I want a 10 gig connection or a 40 gig connection or a 1 gig connection or whatever it is. And that'll be carved off for you, dedicated to you. No one else will be able to interfere with that. So that's how quality of service will work. About physical switches and routers, generally, so the networks, the way they are set up now, the layer 2 networks anyway, you're not going to be able to log into the switches and configure things. They are set up more or less as VLANs on our data plan switch, but you won't be able to configure those. Possible maybe that we'll be able to allow you to configure things via the APIs, but not the switch itself. However, there will be other switches available, including some really more advanced ones. Like we have P4 to Fino switches on their way. And you will be able to basically allocate an entire P4 router or P4 switch to yourself, and then can write the program and configure it any which way you want. We also have Xilinx FPGAs, and we're working with some folks at Boston University to get the P4 code that the P4 systems of Xilinx has set up such that you can turn the Xilinx FPGA into a P4 capable card with two 100 gig ports that you can use any which way you want. Yeah.
I think one thing to remember, right? So the Fabric virtualizes only commodity compute, which is why you get virtual machines, but then all other devices are physical, right? So you get physical ConnectX 5, ConnectX 6 devices, NVMe drives, GPUs, eventually FPGAs, and so on. So that's where you know, if you want to manage that card, if you want to run OBS on top of it, and you want to run your own controller, you're welcome to do that, right? We give you the card, and we create the virtual wires between the ports on that card and whatever else you want on the testbed, right? We will eventually start providing recipes for more complex experiments of this type. Right now, we don't have them. Right now, we just have the basic examples of kind of how to engage the various services. So, but this is, you know, you need to think of it as building blocks. If in terms of logging into the routers, it doesn't help you to know how a specific router works, right? That's not going to help your research. What we're trying to do is kind of abstract that away and let you create the topology you desire, and then control it using the pieces that are programmable for you in kind of more standard ways, like P4 or like OpenFlow or others. I think there's another question there, Paul.
Yeah, and that's a good question for me. So the next question is saying that someone's using Fablab exclusively, and asking if it would make sense to interact with Chameleon to become familiar with Fabric faster. Maybe like in the very short term, that if you want to really get access to the L2 connections between Fabric and one of the NSF clouds, Chameleon's going to be the first one, but I don't see Rob Ritchie or anyone from Utah on that. Maybe I'm just not seeing, but maybe if one of them knows, like we are gonna work with Fablab to have the same sort of stitching capability to Fablab. It's just that we're more familiar with Chameleon, so it's just easier to make that work first and test it out. But yeah, if you want to get started like very soon, then go look at Chameleon, because it'll be done first. But if you wait a little while, they'll have the same capabilities in both sites, both clouds.
All right, so we're already about 6 minutes after 5. I think we have time for one more question. If anyone has one, feel free to go ahead and unmute or type that in the chat box. All right. So an official thank you lets me know it is time to move to our closing remarks. A very warm thank you to Ilya, Paul, and Anita for presenting these talks today. We appreciate your time, of course, and that of our attendees. Please check your inbox for updates in the Fabric newsletter, and tell your colleagues about the new user webinar series, the second Thursday of each month from 12 to 2 p.m. Our next webinar will take place May 12th. We also want to encourage you to register for the MERIF workshop, June 1st through 3rd in Madison, Wisconsin. And finally, please mark your calendars for the next Fabric workshop, which will be held in person in Chicago, September 20th through 22nd. And we'll be sharing details about that as they are available. So anyway, thanks to all of you who have joined today, and we will see all of you soon, hopefully in Chicago. Take care.